Per your request, here's a quick video to get you thinking about Unit 4, how energy is involved in chemical reactions and acids and bases. So here were a couple of slides that I had incorrect on Tuesday night. And the first one is, which has a negative Q value? So I would suggest that as we enter each slide, you pause the video, come up with the answer, and then check it. So negative Q value. So that's the first thing you have to be thinking about. So as I'm thinking about a negative Q value, I'm thinking about exothermic. And I think about that X in exothermic. And if I flatten it, it looks like a negative sign. So that's how one of my little tricks to remember that exothermic reactions have that negative Q value. And so as I'm looking at that and started talking about this, boiling a liquid. Well, I think to myself, okay, so if I'm going to boil a liquid, I'm going to put it on my stove at home. I'm going to have to turn on the energy. I'm going to have to put energy into it. I'm going to pay for that energy too, by the way. And so boiling a liquid would be endothermic. If I think about freezing a solid, so in order to freeze a solid, I've got to put water into my freezer. My freezer is going to absorb that energy from the water. That energy is going to come out right out the back of my freezer. So this one is going to be exothermic. It's going to be putting out heat energy to the surroundings. The freezer is not going to allow that heat energy to stay there. And so it's going to go back out into the rest of my kitchen. Not only is freezing a solid exothermic, but these last two are exothermic as well. And so as we're thinking about a gas, that's our state of matter with the most energy. So as we're decreasing energy to turn it into a liquid or a solid, that difference in energy has to go to the environment. So it would be exothermic. How about this one? Well, yes, that's a dead giveaway now that we've already talked about it. And now on to some acid and bases. All right, so here is our first acid-base problem. Again, have your calculator out, see if you can solve it, pause the video, check how you did. All right, so acetic acid, there's its formula. Since it is an acid, I'm going to use the negative log of the hydrogen ion concentration. And I'm just going to simply substitute that hydrogen ion concentration in, put it in my calculator, and determine the pH, 4.3. So acetic acid, basically vinegar. A fairly weak acid. Meaning that when we put it in water, it's not going to produce as many hydrogen ions as a strong acid would. All right, here's another one. Now, as you're solving this one, hopefully it jumps out at you that this is a base. And so you can't use that pH is negative log of hydrogen ions because we don't know the hydrogen ion concentration. We know the hydroxide ion concentration, and so we have to use the hydroxide ion concentration formula. And so once again, simply substitute in the hydroxide ion concentration, 14 plus the log of that, and you should come up with 12.1. So a fairly strong base here with a concentration or a pH, of 12.1. Even though it is, if you look at the concentration, that is a fairly weak base or a fairly low concentration. But because sodium hydroxide is such a strong base, meaning that all of the sodium and hydroxide ions separate when we put it in solution, that's why it has such a high pH. Here's another. Now, I do apologize because one of my items did not animate correctly, obviously. So this one, I kind of have to scratch my head with. I'm going like, okay, wait a minute. So I know my hydrogen ion. So I know I can find the pH and determine whether it's acidic or basic. But I'm also asked for the hydroxide ion concentration. So there's a couple of ways that you could calculate that. I selected this way. This to me is the easiest way because I know my hydrogen ion concentration times my hydroxide ion concentration in molarity, of course, equals 1 times 10 to the negative 14. So simply by dividing that out, dividing each side by the hydrogen ion concentration, I can find that my hydroxide ion concentration. And I have that rounded to 1 significant figure as provided in the problem. Now I can find my pH, and I chose to just use the pH formula, the negative log of the hydrogen ions, substitute that in, and I came up with 3.3. I hope you did too, and I rounded that to one significant figure. I hope this brightens your day as you're working through Unit 4.